We'll proceed in Jacobian in calculus case study. We are taking many examples in Jacobian case study. Theory is okay, but what about case study? Okay, prior to start with the case study, what is Jacobian? What is integral calculus? Integral calculus has three arena. One is limit, one is integrand, and one is differential. Limit, integrand, differential. There are times when it is not possible to calculate this integration as far as xy Cartesian coordinate is concerned. Then we go with the method of substitution. Now we had given example of a parallelogram, okay, where one is parallel to x-axis side and one can be slant. Let's consider both are slant. Who is stopping us? Now I have a parallelogram. One point is origin 0 comma 0. Other point is 2 comma 1. This is x-axis. This is y-axis. One point of the parallelogram is 0 comma 0. Other is 2 comma 1. Now other point is 3 comma minus 3 and other point is 5 comma minus 2. I believe it was difficult for me to remember it, but this is how it is. Origin 0 comma 0, 2 comma 1, 5 comma minus 2 and 3 comma minus 3. Now this is a parallelogram. If this is the parallelogram, then region is the parallelogram. Now what I have to calculate? X plus y dx dy. X plus y dx dy. Region over the region is parallelogram. Whenever, now it is difficult. X plus y, x plus y dx dy is all right. I don't think anyone would find problem out here. Or, or someone can say even complex, x minus y whole square e to the power x plus y, sine x square plus y square, anything anyone can say. Integrand is sine x square plus y square, bracket close, dx dy over this parallelogram. Who stops us? Means we are trying to calculate volume. If I have x-axis, if I have y-axis, x, y plane. In that sense, I have, whenever in trouble, try to kind of speculate, try to imagine its 3D structure or drawing on pen and paper. Analyzing problem is the biggest thing in solving mathematics. The jumping into solution is a big problem. So if someone has 3 hours to solve a problem, then he can give all 3 hours in analyzing and he may not solve it. I mean, analysis is the main thing. So whatever time it goes in analyzing the problem, that is the main thing. Designing and then making the actual solution, those things are immaterial. Main thing, analyzing the problem. What is the problem? Now if I have xy plane, then if I have integrand is sine x square plus y square. Sine x square plus y square. Okay. Or x plus y. Simple. X plus y. X plus y is the integrand dx dy. Now integration over this parallelogram. What it is? Now if I have xy plane, then the z value fxy, the function over x and y is fxy. The z value is x plus y. At the origin, there is nothing. If I go along x-axis, then it will increase in a kind of linear fashion. If x equal to 10, then z equal to 10. Now in y-axis, it will go in linear fashion. Otherwise, it will also increase, or other places it will decrease. I believe third quadrant minus x minus y, then it will decrease like that. Okay, in that sense. Now, if I am trying to calculate the integration of this function x plus y, it will give, consider x plus y is this surface. Okay, if this surface, integration of this surface along xy plane will give the volume underneath it. Or if I have this equation x plus y, then in first quadrant it will take a slope, positive slope. Now in second quadrant, where x is going negative and y is going positive, so when x is going negative, it will take downward slope, whereas along the x-axis it will kind of, it is a surface and it will go something like this. In when x and y, it will go completely down, and in fourth quadrant, along the y-axis, it will try to bring down, where y is more, along x-axis it will come up. It is very, very weird kind of surface. I believe if this is the surface, then if this is first quadrant, it will go up like this. Second quadrant towards y-axis, it will go up like this. Toward x-axis, it will go like this. Third quadrant completely down. Fourth quadrant toward x-axis, it will go up and y down. It is like that, x plus y. If that is the situation, then I have to calculate the volume that this surface forms with the xy plane. I mean, if I have this surface, I mean, if I have, if I have this surface, if I have this surface, the surface, I mean, this is xy plane, this is xy plane, and this is the surface. If I calculate integration of this surface along xy plane, what if I drop my hand like this, whatever the air that is coming inside this palm, whatever air full, that is the volume I am trying to calculate, and this calculation would happen because surface is that much only. Okay, so whatever is the intersection on xy plane, that is the reason against which we are calculating the integration. This is the surface. If this is the surface, I am trying to calculate volume of the surface, then surface equation. So if this is the surface like this, if this is the surface, then surface equation is some constant height k. K dx dy integration over wherever it falls. That is the intersection falls. That is the intersection it makes on xy plane. That is the region over which we have to calculate the integration. Then it will give the volume. If it falls, whatever the air came in between, that is the volume. If the surface can be like this, or it piercing xy, if pierce xy plane, then this side volume, then bottom side volume, this side volume, all volume I have to calculate. It can be negative plus positive. Like if this is xy plane and it is piercing xy plane like this, half of the way, then this volume typically it will be positive and this volume will be negative. Net volume will be kind of zero. Well, how we take it, or that also I can make it positive, then how we take it. Okay, that is the concept. But anyway, now if this is the scenario, we are trying to calculate the volume of a surface, that is x plus y dx dy over the region. Now this xy plane is infinite. I have taken this big only, but it is infinite, very big. But we don't want the integration over full big xy, full big surface. I want this surface has intersection on xy plane. For xy plane, or rather if I say on xy plane, I am taking one parallelogram. I have drawn one parallelogram on xy plane. For that parallelogram, if I go and map on this surface, whatever the region coming on this surface, under that whatever volume comes, that volume we are calculating. That is the region in xy plane. In that region we are calculating the volume. Or someone can consider, if I have a parallelogram 0 comma 0, 2 comma 1, 5 comma minus 2, 3 comma minus 3. If someone draws it, a parallelogram, then underneath parallelogram, this is the reason for the integration. This is the reason for integration. If I draw this parallelogram on this xy plane, then I have to take x comma y only inside or along the curve of the parallelogram, boundary of the parallelogram, not outside it. Outside it, z value is 0. Outside it, z value is 0. But inside the parallelogram, if I take any x comma y, then z equal is x plus y. But this z value x plus y go beyond this parallelogram, very big. But I don't want that much. Whatever this parallelogram is, if I take xy inside this parallelogram, for that xy I calculate x plus y or fxy. Whatever the points are coming in the z direction, if I kind of connect all the point, it forms a surface. I want volume under that surface only, or surface under which the parallelogram is there. It's the surface region. There is a big surface region. Inside that, I cut out a surface region. That surface region, if I map on xy plane, it should result in the parallelogram. Otherwise, I consider height as 0. It doesn't exist at all. This is called limit. We have talking about this reason many times. If this Jacobian is crystal clear to any calculus person, then machine learning and artificial intelligence is like a cakewalk. Jacobian is that much important because at the end, in machine learning, artificial intelligence, someone has to tackle vector and calculus. Vector and calculus, but sometimes it is very difficult to solve it. At that moment, people need substitution, method of substitution. When you need method of substitution, then this method, this Jacobian. Now if I have integration and I have a limit on xy plane, fxy and dx dy, then dx dy, if I take x equal to uv, x is an independent component, y is an independent component. That is xy plane, whereas z is dependent component. So now z is dependent upon xy plane. Now with this fundamental, I am not able to calculate the integration. Then now I'll take another independent component u and v, where x is a function over u and v, y is a function over u and v. Means if this is xy plane as independent component, I have another plane called u and v. Now this xy plane is dependent upon u and v, and upon xy plane our fxyz is dependent upon x and y. We have talked about cross Jacobian, where we take out xy plane completely and make our z dependent upon u and v directly. Cross Jacobian, partial Jacobian, full Jacobian. Now we are doing full Jacobian as per the cases. Many case study we have done in cross Jacobian and partial Jacobian. Very interesting, mind blowing, amazing. Now, if this is the scenario, now someone can think about convert. Now, if I going for method of substitution, xy is converted to u and v, then dx dy, that is the differential part, that is dxy plane actually. Dxy plane in Cartesian coordinate can be said as dx dy. Dxy plane by duv into duv. I can write like this. Who stops me? Dxy plane by duv into duv. That is dxy plane by duv into duv. duv becomes du dv, and the dxy by duv is called Jacobian. That will be attached. Extra thing someone gets if he does the transformation of coordinate as far as differential part is concerned. Now integrand part directly someone can substitute x to f uv, g uv function g over uv, and y to h uv function h over uv. Now the classic comes how to change the limit. Okay. Now for parallelogram, we will go with the example. I am not running away. Okay. Now, but let's kind of think about this Jacobian part. This is the cracking part. Cracking part is everywhere. I'm not saying cracking part. But if someone is saying that dxy plane is dx by duv into duv, that is du dv. dxy by duv is nothing but dxy by duv is nothing but if I have a position vector p, uv plane, xy plane. I have a surface on xy plane. I have a surface on uv plane. This surface is mapped to surface on xy plane. What is mapped? Now, xy plane has a circle. Xy plane has a circle of radius a. Simple, right? Now, I want rectangle in another coordinate system called u and v or theta and r. Now, is it possible that my circle would be mapped like a theta and like a rectangle in some other coordinate system? Okay, I have xy plane and I have a surface like a sphere. Surface is a sphere. Is it possible that this spherical surface would be mapped on xy plane as a circle? Here it is a spherical surface, but here it should be a circle. Similarly, that is the fxy equal to square root of a square minus x square minus y square. Similarly, if I have a circle in xy plane, is it possible that it will be mapped like a rectangle in another plane? I generally call it theta r plane. If that is the case, or uv plane, then what is the relationship? Now x equal to u cos v and y equal to u sin v, or x equal to r cos theta and y equal to r sin theta. If this is the transformation function if I take, then my circle in xy plane would be mapped like a rectangle in theta r plane. dxy by d theta r, this is the Jacobian. If that is the case, then if I make one unit, it is like a connected thing. Both are connected now. Through a function, both are connected now. If I make one unit of area change in theta r plane, accordingly this circular region will change because they are attached to each other. How much unit of area change it would see? That is dxy by d theta r. If there is a one unit of area change in theta r rectangle, how many unit of area change it brings in xy plane in the circle? Means it is like I have a big robot and I have a small robot. If I change the small robot anything, the big robot changes. Head of the small robot, if I rotate, big robot head is rotating, like connected each other. This is a one small model, this is a big model. Similarly, in theta r plane, I have a rectangle that is connected to a circle in xy plane. If I make a small change here, it would give a change in the circle here. dxy by d theta r. Can I think of reverse fashion? Can I say that my now here xy plane is dependent upon r theta plane? This is independent, this is dependent. Can I say reverse fashion? xy plane is has xy plane and theta r plane. Now xy is a function over theta r. Can I consider theta r is a function over xy? Theta r is function over xy. If that is the case, then dxy by d theta r, if it talks about changing one unit of area change in theta r brings how many unit of area change in xy plane? What about d theta r by dxy? If I make one unit of change in circular region of xy plane, how many unit of change it makes in rectangular region of theta r? Okay, if this is the reverse mapping, if this is the straightforward mapping from theta r to xy plane, then xy plane to theta r is reverse mapping. If it is reverse mapping, then multiplication should be 1. Can someone prove it? If someone can prove it, then it is really kind of logical what we are doing. What is dxy by d theta r? If there is a position vector in xy plane, Now in xy plane, I have a circle. In xy plane, I have a circle. I have taken one example. On the circle, if I take any point P, that is x comma y, xi plus yj, then what is dp by d theta cross dp by dr? We have proved it that dp, in that case, dp by d theta cross dp by dr is dxy by d theta r. Similarly, if this is a rectangle here, and if I take any point P here, position P here, that is theta comma r, then the vector is theta I plus, the vector P is theta I plus rj. dp by dx cross dp by dy, that is nothing but d theta r plane by dxy. Multiplication should be 1 if dxy plane by d theta r plane into d theta r plane by dxy. If it is 1, then actually we corroborate, okay, this equation that dxy plane by d theta r plane is nothing but dp by d theta cross dp by dr. Okay, anyway, how we will solve it? I'm not running away. We will solve it that dxy plane by d theta r plane into d theta r plane by dxy plane is 1. Mathematically it is 1. I make cross cut, it is 1. But through vector form it should be 1. Means dp by dx cross dp by d theta, where p is in xy plane vector, in circular region, dp by d theta cross dp by dr, okay, actually it is equal to 1 by dp by dx cross dp by dy, where this p is p position vector in rectangular region in theta r plane. Okay, that is the scenario. Okay, can someone, we have already proved it that if it is xy plane and this is a surface that is z, and if I take any point here P as position vector, then dp by dx cross dp by dy is nothing but d surface area, this d surface area by dxy plane. Means if this is xy plane and if I draw a rectangle here, and this rectangle go and map into some surface area here, and if I change one unit in rectangle, either growing or shrinking, how many unit of change it makes in this area, it is mapped on the z, that is dp by d. That is, if I take any position vector p here, xi plus yj plus zk, that point is x comma y comma z, xi plus yj plus zk, if that is the position vector, then dp by dx cross dp by dy is nothing but how much the surface area would change, mapped surface area would change if there, for that the intersection region xy plane, if there is a rectangle and 1 unit of change in happening meter, 1 unit of change in area is happening in xy plane, dp by dx cross dp by dy. Similarly, if I have xy plane, I have theta r plane. If I have a position vector in xy plane, then dp by d theta cross dp by dy is nothing but dxy plane by d theta r plane. Similar fashion. But what? Mathematics is not similar and approximation. Can you prove it? Someone would say, can you prove it? I don't go with your sentiments that if I take xy plane, if I take any point P, then dp by d theta cross dp by dr is nothing but dxy plane by d theta r plane. We will prove it. We are not running away. Okay. So if there is a circular region, this is what example we are taking. If I take any point P here, that is xi plus yj, since it is xy plane, xi plus yj, x is nothing but a function over theta and r, y is nothing but function over theta and r. Okay, now if that is the case, then along the x-axis I move delta x. One point is x comma y, I move along x-axis, that is x plus delta